We will now look into creating glass with the RBD material fracture node. Although creating glass is a relatively straightforward process, it is very tricky to create nice glass fracturing without this node. So usually the RBD material fracture node is my first choice when I need to fracture glass. So let's take a look at how this works. I have a very simple box ready with a transparent material just to make it look interesting. And I will lay down a new RBD material fracture node and I will connect it to the box. So remember, by default we have the concrete material type on, and first of all I will change this to glass. And by default we have one single scatter point. So if you go to the impact points, scatter points, by default there's only one. So of course we could increase this to 2, 3 or more points. The thing with glass is that you usually want to have a very precise positioning of your impacts. So for now I will turn off the scatter points, and just as we did with concrete on the last video, I will add some points as seeds for the fracturing. So let me click the tab key and type add, and I will turn on 1 point, or point number 0. Make sure to select the add node, go to the perspective and press enter just to be able to move around the point in space. So I will position it just where I want the fracture to be, and I will connect this node to the 4th input of the RBD material fracture node. So make sure now to select the RBD material fracture node and click on the input points to use this new created point as a seed for the impact. And of course, if we eventually want to add more points, we can go back to the add node, click on the plus icon up here, turn on point 1, and again we can move it around to position it exactly where we want it to be. So I will turn off point 1 for now. I'll just keep point 0. And let's select the RBD material fracture node to take a look at its properties. So first of all, I'm going to click on the cracks tab, and this is where we'll find the main properties for the glass fracturing. So first of all, the radial crack number is probably one of the main features that we'll notice when looking at fracturing glass. So it is these radial lines that go from the center of impact outward. So let me increase the radial crack number to say 40. So now we have a much more detailed fracture. Now you can increase the number variance to make it look a little more irregular. So usually the higher this number, the more irregular the cracks will be. If I set this to 0, for example, we will have a more regular number of cracks. So let's bring it back to, let's say, 8. Now the concentric crack is the distance that we'll get from the center of the impact point outward in terms of this breaking. So let me increase this number to, let's say, 0.2. So now we have much less of these cuts, these radial cuts. And if we decrease this value, of course we will have much more cuts and with a much less spacing. So I will leave it like this for now, just for us to better see the discontinuity frequency. So this is a little bit like a noise pattern. If I increase this value, the patterns will tend to be smaller, and if we decrease this value, the patterns will tend to be larger, a little bit like the noise patterns. So again, we can decrease the size or increase it to make these gaps larger. So let me increase the width a little bit. Let's go with this for now. And now let's take a look into the chipping. In my opinion, chipping, you should always use this value. So I will click here on Enable Chipping, and you'll notice that some of these very large shards will start breaking up to make it even more irregular. So usually we have the ratio. If we increase the ratio, more of the shards will break apart, which I really like. Of course, you can change the seed just to change the distribution of these cuts. And by changing the corner ratio, you can also increase these cuts more towards the corners of the object. So if we reduce this value, you will notice how we have less cuts on the corners. So I will increase it. I really like how these cuts look. And let's go now to the detail, which is also a very important parameter. So if you take a look at the front view, I'll press spacebar 3 just to look these cuts from the front. They're kind of soft and kind of regular throughout the length. If we turn off the edge noise, they're perfectly linear, which is very unnatural. So what I usually would recommend is turn this value on and play with the size. So in this case, I think the size is quite large. I will try to decrease the size of the detail, probably to half, and increase the noise amplitude, let's say twice as much. And we could increase the noise frequency just to make this noise much smaller. So I think I overdid it with the noise amplitude. So I think this is starting to look much better. And another very important thing that we need to remember is that the RBD material fracture is generating for free the low resolution version of this geometry and a constraint network in case we need to do some destruction later. So let me add a null object just below the RBD node and connect the third output of the node to the null. So right now we're taking a look at the low resolution geometry. So especially if you take a look at the edges, notice how this is much lower resolution than the first input, where we have more subdivisions and more jagged edges. And again, we will talk about simulating in later tutorials. Just have in mind that whenever you use the new RBD material fracture workflow, we have this information for free. So let's take a look at the constraint network. And of course, if we take a look at the groups that have been generated for the geometry, we will have several groups created that can later be very useful to generate particles or additional detail like materials or even displacement. So let's very quickly add a blast node just to take a look at the groups that were created. Click on Delete Non-Selected and select the group that you want to check. So in this case, we're only seeing the inside edges of the chipped glass. We can also take a look at the concentric inside pieces, which can be very useful. And in general, the glass shattering has a lot of groups that will be created just in case we need them later.